Bismillahirrahmanirrahim. Assalamu alaikum class. Today we are going to have an online lecture regarding programming using Python. I'm recording this video lecture just because there is some uncertainty regarding internet availability tomorrow. So in order to ensure that we can have the class, I'm recording this lecture. Now for those who have not practiced Python before with us in the class, I will start with the very basics. Anaconda.com, this is one of the ways in which we can program Python. I am going to use this in my lecture. Anaconda has Jupyter by default, the notebooks which work inside the Google Chrome. So in order to download Jupyter notebooks, you need to navigate to anaconda.com. Click on this free download button at the top, right next to sign up button. You can either subscribe by using your email ID, or you can skip the registration process and move directly to the available options to download Anaconda. And if you use Windows laptop, then 64-bit installer is available. Installers are available for Mac and Linux as well. After you install this anaconda.com, you shall be able to access the Jupyter notebooks. For this, you can navigate to your start menu and simply type Jupyter. It will automatically search the app and open that for you once you click on it. A black DOS type of window will also open, and you are required to keep it that way. Within Jupyter Notebook, if you want to start a new file to write down the Python code, it's called kernel. You need to navigate to this button new, click on this, and Python 3 kernel, IPY kernel. You can click on this to create a new file. I have already created the file for this truss analysis. Once you click on the file, it will open up like this. So I'm going to discuss this code with you today briefly. This whole code uses basics of FEM matrix method that makes the basics of that takes the basis from stiffness method. The result looks like this. I am starting with the result so that you should already know what we are heading forward towards. So if you have a truss, you will enter the number of nodes. Corresponding to each node, it will demand the coordinates, x coordinate and the y coordinate. Similarly, corresponding to every element of the truss, it will demand the user to input modulus of elasticity, cross-sectional area, the starting node ID, ending node ID, and so on. For the support conditions, it will demand how many nodes are constrained, and corresponding to the nodes which are constrained, it will demand you to input 1 if the constraint is in x direction, 2 for y direction, 0 for both direction. Here, because some students get into a confusion, let me clarify that because it is a truss, we can only have roller or hinge type of supports. We cannot have a fixed support directly appended to a node of a truss. Later on, corresponding to the applied loads, it will demand how many nodes are loaded. Corresponding to each node, it will demand node ID, the force value or magnitude in x direction and y direction. It will calculate the nodal displacements of the truss. It will calculate the reactions, and it will calculate the element stresses and strains. So this is the output of the code which is available or visible on your screen. Let's start discussing the code one point at a time. The first and foremost is the library that has been imported. Remember that Python has a lot of libraries available. It stated that more than 200,000 libraries are available that can be used, which can be imported, and the codes available in those libraries can be used directly in Python. In order to import any library, you can use the function import library name. In fact, only import and library name, that is enough. We don't need anything after this. However, some libraries have very lengthy names, so in order to make it easy for writing down the code and to remember the name of the library, we sometimes give it a nickname. So I'm saying import the library called NumPy as NP. It will be called as NP during the code. So whenever I will need this library, I will need to call this library. Instead of writing down the whole name, I will simply write NPy. Moving on. The next step is input of the truss data. Remember, we are trying to solve a truss. Today we are discussing a two-dimensional truss. So I can update this message as two-dimensional truss. However, at a later stage we need to convert this to a three-dimensional truss. So when we start typing the code, the first step in the algorithm should be number of nodes available in the truss. How many nodes are there in the truss? Here we will use a variable called nn. You can name it anything else if you like. I have used nn because for me it stands for number of nodes. Remember that nn is capital. The alphabets are capital. In Python, small alphabets and capital alphabets are not treated as one or same. So if I'm using capital N here, I will have to use capital N anywhere else whenever I use this variable. Then input command is input. Within brackets you can write down your message. So I've written the message, enter the number of nodes. However, by default the input format in Python is string or text format. So we need to convert this to numeric. In numeric or numbers, we primarily have two types of data in Python: integer or floating decimal places. Here I have used integer, int. This function int will convert whatever value is given as an input by the user to an integer. Remember, integers cannot have decimal places. However, floating numbers can have decimal places. I have used integer because the number of nodes in a truss cannot be in decimals. They have to be an integer. They will be either 3 nodes, 4 nodes, 5 nodes, but there cannot be 4.5 nodes or 5.2 nodes. Therefore, I have converted this to integer. After determining the number of nodes, the next step should be the x and y coordinates of each node. Remember that x and y coordinates of each node that has been taken as an input from the user will give us very crucial data related to the length of every element, angle of inclination or orientation of every element of the truss. Please consider that in this analysis, every element will be treated as a vector. Moreover, the number of the x and y coordinates of every node can be directly used to calculate these values instead of demanding the values from the user. So I begin with defining two lists or arrays. You can say array, although array is not directly used as a term in Python. X and y, two variables which will contain a number of values corresponding to x coordinates and y coordinates of every node present in the truss. This code line number 10 is a for loop. The variable which is going to dictate the for loop is I, and its values will be same as the values stored in n, the number of nodes. So if nn is, for instance, 7, this loop will run 7 times. Every time the loop runs, first of all it will print the number of node and demand the x and y coordinates corresponding to that node. X dot append, y dot append will take input from the user and append the values of the user or input given by the user in x and y variables. So by the end, once the loop run completes, these two x and y variables will have all the values of x coordinates and y coordinates. Remember, I have used n as capital here. As told before, in line number 4, once the variable was created, the name was kept in capital alphabets. So whenever I need to use this variable or call this variable, I'll have to use capital letters. Then again, in line number 4, in order to convert the input from text to a numeric format, we used integer because number of nodes cannot be in decimals. However, the x and y coordinates do not have that limitation. The value of coordinates can be in decimal places. So I have used float to convert the input given by the user from text format to a numeric format which can have decimal places. So with this, from line number 7 to line number 14, our input sequence for the x and y coordinates of nodes end. From line number 16 to line number 23, we have the code which take input of the element data. So the element data should start with asking the user how many elements are there. Remember, in a truss, number of nodes cannot be used to calculate number of elements because same number of nodes can have different number of elements depending upon the shape and configuration of a truss. So we need to ask user about how many number of elements are there. Later, corresponding to each element, we need to take input of modulus of elasticity, area, and the starting and ending nodes. So here we have used another loop in line number 22. It begins with line number 22. J is the variable which is going to dictate this loop, and this loop will run equal to the number of nodes. How many times the loop will run? Equal to the number of elements. Sorry, I mistakenly said number of nodes. It's number of elements. So we begin with displaying the number of elements for which we need the data. So E and A were already created as variables. Append is being used so that we can take input and add the input to the same variable in form of a list. So we will take input of modulus of elasticity and later cross-sectional area. Because the input is in text format, we need to convert that to numeric, and here we are using floating decimal place values. So this will append the input values to E variable and A variable. Later we will ask starting node and ending node and append these two values in the variable called dir. So in this way we have taken input of modulus of elasticity, cross-sectional area, and starting and ending nodes of each element. With this, our geometric data input is over. Line number 31 onwards contain the input for support system. Every node that have a support attached to it is called a constrained node. A constrained node means it cannot, you can say, move in one or two particular directions. Let me repeat. In trusses, we can only have rollers or hinges. We cannot have fixed supports because in trusses, the elements do not support movements. So for the support system, we begin with taking input of the number of constrained nodes. So I've created a variable called NC to take input of number of constrained nodes and converted that to numeric by using int. For the same reason, we converted number of nodes and number of elements to numeric using int. So we display a message to the user that if the node has a constraint in X direction, then the user needs to enter 1. If the constraint is in Y direction, the user needs to enter 2. If the constraint is in both directions, user need to enter 0. Later on, based on what user entered, we will decide in the force vector and the displacement vector where we need to input the 0 values of displacement and where we need to calculate the reactions. Later we have created a variable called CONS for constrained nodes. Again, a loop will run. The number of runs will be equal to number of constrained nodes. First of all, node ID will be demanded from the user so that we can know which node number has a particular support on it. Constraint type is demanded from the user. Remember, constraint type has been displayed to the user and the code is written in line number 35. And the values are being appended in this variable called CONS in line number 42. Similar to the input sequence, we have input of force data. NF is the variable which will store the number of nodes that have force applied on it. The input has been converted to numeric by using int. In the loop, we will first of all demand node ID of the node on which external force is acting. The value of force in x direction and y direction is demanded separately. In this case, where we are demanding the value separately, user will have to calculate x component and y component of the force if the force is acting at an angle other than x direction or y direction. FORC named variable gets all these values appended in it to form a two-dimensional list. So this was the input sequence of the code. Today we will stop our online lecture, this video lecture here at this stage. I will definitely like you to try and develop this stiffness matrix yourself. If you are not able, then we will discuss this in detail in the forthcoming lectures. The code from this lecture has already been shared with the students. I hope you will be able to understand this code. Do practice this and let me know if you have any questions. My email ID is ali@uit.edu.pk. Allah Hafiz.